Welcome back. We're continuing to look at graphing rational functions. In this video, we are going to look at the example x minus 1 over x squared minus 3x minus 10. The first thing I want to do in all of these problems, the first thing I want to do is fully factor. So I'm going to make sure that I fully factor this. My numerator is fully factored as x minus 1, but my denominator I'm going to need to factor, and this factors to be x minus 5 times x plus 2. So I'm going to find my domain restrictions because any number can't be divided by 0. So anything that will give me 0 in the denominator will be a domain restriction. So x cannot be equal to 5 or negative 2. Now that I have fully factored this, I'm going to try to simplify by canceling out any terms that are any factors in the numerator and denominator that are common. And I don't have any factors in common, so this is fully simplified. So now that I have fully factored and simplified, I see that nothing canceled out. So in my fully simplified version, the denominator exclusions are going to become vertical asymptotes. So my vertical asymptotes are at x is equal to 5 and x is equal to negative 2. Because all of my domain restrictions turned into vertical asymptotes, there are no holes in this graph. The next thing I want to look at is horizontal asymptotes. And when I'm looking at my original function a of x over b of x, the degree of the numerator over the degree and the degree of the denominator are going to be used to help me decide what my horizontal asymptote will be. So the degree of the numerator is first degree, it's a linear, and the degree of the denominator is 2 because it's a second degree, it's a quadratic. So n is less than m. When n is less than m, y equals 0 will be my horizontal asymptote, and there will be no slant asymptote. You will always have one or the other. You will never have both of these. So the next thing I want to do is find my x-intercepts. And if I think about this, if I say my x-intercepts happen when y is equal to 0. So I'm going to do my x-intercept math up here. So y is equal to 0. That gives me 0 is equal to x minus 1 over x squared minus 3x minus 10. So when I multiply both sides by this denominator, it gets multiplied by 0 and just disappears. So I really could just look at 0 is equal to the numerator. We talked about that a little bit, that a of x equals 0 will give me my x-intercepts. So setting the denominator equal to 0 gives me my domain restrictions, and the numerator will give me my x-intercepts. Okay, so x is equal to 1 is my x-intercept. So I have an x-intercept of 1, 0. My y-intercepts are going to be when x is equal to 0. So when I do that, I get y is equal to 0 minus 1 over 0 minus 10, or 1/10. So this is the ordered pair 0, 1/10. All right, I'm going to come in and graph my asymptotes. So here I have x is equal to negative 2, and x is equal to 5. And then I've got y is equal to 0 here. I have two vertical asymptotes. So I'm going to need to divide my graphing space or my table into 3 sections. I need at least 3 points per section. What I end up finding is a lot of the times 3 points isn't quite enough, and I'll end up just finding more points. In general, using your calculator for this is going to be a good idea to find your ordered pairs. So what you're going to do on your calculator is you're going to go to y equals, and you're going to input your original equation into y1. So I'm going to input in the numerator x minus 1, and in the denominator x squared minus 3x minus 10. Then I'm going to go to my table, and I'm going to go to my table, and I'm going to set it to ask for my independent variable. So I want my independent variable to be chosen by me. All right, so 1, 0 is going to be somewhere in here, and 0, 1/10 is also going to be in this middle region. But I feel like I need more points than that. So I also want to go with -1 and 4 in here. So if x is -1, y is 1/3. And let's just check at 0 to make sure that that works. And at 1, I'm getting the values I expect, so this is 1/3. And when I plug in 4, I get -1/2. So now if I go ahead and graph this, 0, 1/10 will be there, 1, 0 is there, 4, -1/2, -1, 1/3. I have no idea what's going on. So I'm actually going to find maybe 4.5. That's going to give me -1.077. So a little bit further down. So now I can see this graph is kind of sloping that direction. And maybe -1.5. It's going to give me 0.796 or 0.769. So up a little bit higher. So it's kind of curving up there. So what's going to happen is this is going to approach this asymptote, and then we are going to curve across and approach that asymptote down there. I'm going to label my x and y intercepts just for completeness, and then I'm going to go on and do the outsides. Okay, so I'm thinking I want maybe 5.5, 6, and 7 to the right. So 5.5 is going to give me 1.2. 6 is going to give me 5/8. And 7 is going to give me 1/3. So 5.5, 1.2, 5/8, 1/3. I can kind of tell that this is curving from this asymptote down to this asymptote. And in the left region of my graph, I'm going to pick -2.5, -3, and -4. -2.5 is going to give me -0.933. -3 is -1/2. And -4 will give me -5/18. So that's going to look like this. I'll have a point here, here, here. So it's a little hard to tell, but it is curving in this direction. So now that I have my graph graphed, I just want to go through my checklist. I found my domain. I simplified by canceling factors. I didn't need to do synthetic or long division because the degree of the numerator was lower than the degree of the denominator. I found all the holes in vertical asymptotes and the horizontal or slant asymptotes, found my x and y intercepts, and at least 3 points per region, and I graphed it. So this problem is complete.